welcome back to today we're doing
transversals. We're doing some work. We're doing some geometric work with transversals and parallel lines in order to be able to figure out the measurements of missing angles or figure out the measurements of angles that are included. All right. So this is called a transversal. All right. Just like right here, a line that cuts through two parallel lines. Right. All right. Well, a transversal is actually a line that cuts through two lines or more than one line. But when the two lines that the transversal cuts through are parallel, that's a symbol for parallel, right? Two vertical lines, that's the symbol for parallel, right? Then we can figure out certain information about the angles that are created by the transversal and the parallel line. So angle 1 was created by the transversal in line L. Angle 4, angle 3, this 30-degree angle were created all by this line, this transversal cutting through this line L. All the same thing when the transversal cuts through line M. It creates angle 5, angle 6, angle 7, and angle 8. All right, so we're about to get into some geometry. All right, so, and there are rules. There are rules. When you have parallel lines and a transversal, there are rules that indicate to us what the measurement of the angles will be. All right, so dig this. So angle 1, let's start with angle 1. If this angle is 30, right, and this don't even got to do nothing to do with transversals, but this is called a linear pair. All right. Now I'm gonna throw a lot at you right now. You're probably not gonna remember all of it, but we're gonna practice this over and over again. All right. So this is called a linear pair. Linear, the root word of the word linear is line, right? It means they form a straight line. This angle and this angle together form a straight line. A straight line is also an angle, right? The measure of a straight line, the angle measure of a straight line is 180 degrees. So that means that these two angles together add up to 180 degrees. So if you know that, Assata, if this angle is 30 and the two angles add up to 180, what does angle 1 have to be?
40.
So you telling me that 30 plus 40 equals 180 degrees?
Wait.
You telling me that 30 plus 50? Okay. All right, that's what I thought. That's more like it. Again, a linear pair. A linear pair. Two angles that add together and make a straight line. The angle measure of a straight line is 180 degrees. So therefore, the two angles must add up to 180 degrees. 30 plus 1, if you set it up algebraically, it would be like this. 30 plus angle 1 is equal to 180. And then you do algebra, subtract 30 on the left, subtract 30 on the right. So this is why we have to know algebra in order to be successful at geometry. Angle 1 equals 150. All right, so that's 150. Now, if this is 150, there's another rule called the vertical angles rule or the vertical angles theory. If two angles they share a vertex, the vertex is like the point where the angle starts, basically, right? Where the two rays meet to create the angle, right? This vertex right here, these two angles share a vertex and they're non-adjacent. They're not next to each other like a linear pair. And the rays or the lines that create the angles are connected, right? Essentially, the way I remember it from when I was in 9th grade and I took geometry for the first time, right? When an X is formed, like Malcolm X, when an X is formed, the angles that are across from each other are always congruent. So angle 1 is equal to angle 3. Angle 1 is equal to angle 3. So then what's the measure of angle 3? I just said angle 1 is equal to angle 3. So what's the measure of angle 3? 150. Right. See, in geometry, we use critical thinking. Geometry teaches us how to think critically. All math classes teach us how to think critically, but geometry is very direct with it. So now angle 1 and angle 4 are a linear pair, right?
Yeah.
Because they form a straight line and they're a pair. They're adjacent to each other. So what does angle 4 have to be?
150.
So you're telling me that 150 plus 150 equals 180?
30.
That's 30. So angle 4 must be 30. Also, isn't angle 4 and this 30-degree angle, aren't they vertical angles? So that's another way to figure out that angle 4 must be 30. So we had two ways. We had two options. So that's 30. That's 150. Now, down here. Now we're dealing with the transversal. Now, there's something called angle 3 and angle 6 have a special relationship. right? Angle 3 and angle 6 have a special relationship. This 30-degree angle and angle 6 have a special relationship. Now, this is the angle, this angle right here, and this angle right here, angle 6. Are you paying attention?
Mhm.
They're called corresponding angles. Corresponding angles, right? They're on the same side of the transversal, and they're both above their respective parallel line. 30 is above L, 6 is above M. 30 is above L, 6 is above M. 30 is above L, 6 is above M. And they're on the same side of the transversal. They're both on the right side. That's called corresponding. Corresponding angles are congruent. An equal sign with the squiggly line on top, that's the symbol for congruency. So that means that, what does angle 6 have to be?
30.
30, because they are congruent. That's not right. I don't need an angle symbol. I need a degree symbol after the number. So that's 30 degrees, right? So this is 30. Now, there's another way we could have figured that out, because angle 3 and angle 6 have a special relationship too. Those are called consecutive interior angles. They are supplementary. You know what supplementary means?
No.
Of course you don't, because I didn't teach it to you yet. Supplementary means the two angles, they're like a linear pair, right? They're similar to that. Supplementary means that the angles add up to 180. They're supplements of each other, meaning they add up to 180. So isn't that how it works out? What's 150 plus 30?
80. 180.
Right. So that's another way we could have figured out what angle 6 was, because you know what angle 3 is, and angle 3 and angle 6. So it's about the relationship. It's about the relationship, right? So when we're looking at problems like this in geometry, we first look to see, well, what's the relationship between these angles? If they're corresponding, we know they're congruent. If they're consecutive interior, we know they're supplementary, which means the two angles add up to 180, right? They could be alternate interior angles, which means they're congruent. They could be alternate exterior angles, which means they're congruent, right? So what's an example of alternate exterior? So alternate, angle 1 and angle 8. Angle 1 and angle 8, they're on alternate sides, like two people being on opposite sides of the street. I'm on this side of the street, you're on the other side of the street, right? Angle 1 and angle 8. Look at that. That's the transversal is the street, right? Angle 1 is on the left side, angle 8 is on the right side. And they're exterior. If you think of this as a box, think of this space in here as a box, right? This is the interior of the box. This, everything above it, exterior. Everything below it, exterior. Everything above it, exterior. Everything below it, exterior. Angle 7, exterior. You watching? Angle 8, exterior. Angle 1, exterior. 30 degrees, exterior. Right? Angle 1 and angle 8 are alternate exterior angles. They're on alternate sides of the transversal, and they're outside of the box that is formed by these two parallel lines. So alternate exterior angles are congruent also. So if you know angle 1 is 150, what's angle 8 got to be? There are alternate exterior angles. Alternate exterior angles are what? Congruent. Congruent.
150.
So angle 8 is what?
150.
Right. It's just a bunch of rules. As soon as you memorize the rules, you're going to be straight. Now, what about angle 7?
30.
How you know it's 30?
Because they're both on the outside and they both have to add up to 180.
Well, them being on the outside don't got nothing to do with that. But they're a linear pair, right? Just like angle 1 and 30 degrees in this angle, we're a linear pair. They're adjacent to each other and they form a straight line, right? Also, angle 7 and angle 30 are alternate exterior angles, right? Yo.
Yeah.
Angle 7 and the 30-degree angle are alternate because the 7 is on the left side of the transversal, 30 is on the right side of the transversal. They exterior, because here go the box. There's a box formed by these two parallel lines, right? The 7 is outside of the box. The 30 is outside of the box. They exterior. So that's another way we would have known that angle 7 was 30 degrees. All right? Here's another thing. Angle 7 and angle 4 are corresponding angles. They're on the same side of the transversal. Same side of the transversal. And they're both below their respective parallel line. Angle 4 is below L. Angle 7 is below M. Angle 4 is below L. Angle 7 is below M. That means they're corresponding. Corresponding angles are congruent. So there's all these ways we can figure out the angle measurements. Now let's do angle 5, and then we're going to be done. So angle 5 and angle 1 are corresponding, right?
Mm-hmm.
So what does angle 5 have to be?
150.
150, because angle 1 is 150, and corresponding angles are congruent. See, now you're in 7th grade doing geometry. We don't got to wait for the school. Parents, don't wait for the school to teach your children these things. You can teach them these things, right? This is not on her curriculum for this year. Does that matter? No. I make my own decisions, right? I'm the primary educator, right? The school is going to supplement what I do. And you as parents, y'all can move the same way, right? We got plenty of content on all this math, plenty of content. You can tune in, lock in, and have your children learn whatever math you want them to learn. All right. So look, we have found out all of these angle measurements: angle 1, angle 3, angle 4, angle 5, angle 6, angle 7, angle 8. And what did we not talk about? We talked about corresponding angles. Oh, alternate interior angles. Alternate interior angles are also congruent. Alternate interior angles are also congruent. Yeah. So like angle, look, Assata, angle 3 and angle 5. Alternate sides of the transversal, and they're interior. So they're inside this box. The two parallel lines form a box, right? It's rectangle. It's like a box. They're inside the box. Angle 3 and angle 5 are inside the box. Angle 4 and angle 6 are inside the box. Notice that. See, we already knew angle 4 was 30 and angle 6 was 30. Alternate interior. Alternate. Left side, right side. Left side, right side. Alternates. Like some places got alternate street parking. On Monday, you can park on the right side of the street. On Tuesday, you can park on the left side of the street because they be doing street cleaning, right? It's called alternate street parking, right? Same thing in geometry. Alternate interior angles, alternate exterior angles. All right. So just something I wanted to introduce Assata to, and hopefully, because again, we don't gotta wait for the school. We don't gotta wait. Like she can learn this now. She's capable of grasping this material, and your children are too. So don't wait. All right. Don't even wait. All right. So that's that. Any final words?
No.
Okay, you gotta go finish braiding your hair? Yeah, yeah, sure you do. All right. See y'all later.